In this chapter, we will be analyzing rational expressions and equations. In this lesson, we will be looking at how to multiply and divide rational expressions.
All right, hi everybody. So in this lesson, we're talking about multiplying and dividing rational expressions. Okay, so here's the procedure, if you will. First of all, I want you to factor the numerators and denominators. I want to break this thing apart here, and the reason we want to do that is, the purpose of that is to simplify. Because multiplying, dividing, we're basically just putting terms together, okay? So, like, bear in mind, like if I've got A over B, and I'm going to multiply it by C over D, remember that with multiplication, you just go straight across. So essentially, we're just going to slide these things together. So AC over BD, we just write them together like that. Essentially what we're saying here is, the order of multiplication and division is a little bit fluid here. I can play with it. I don't have to divide, then multiply. I can multiply the numerators, denominators, and then divide afterwards. Like the order is, I got a little bit more freedom there, okay? So simplifying, or factoring, I should say, factoring allows us to look for places where we can simplify, where we can find a 1. Because remember, if you've got A over A, that cancels down, it becomes a factor of 1. Okay? Now, we do have to identify the non-permissible values, and you really do need to do this. You need to be very diligent about doing that, or else the answer that you get isn't going to be quite correct. It won't actually be equal to the original expression. So you got to be careful about that. Now, we're going to reduce the complete factors. Again, that's just finding the 1. Okay, so like if you have if we had an A up here, let's say for example that this was an A. Okay, let's say this is A over B multiplied by C over A. When they're in factored form, if you've got a factor that's shared there, it doesn't really matter whether that denominator is in the first fraction or the second one. They will cancel here again, because the order with multiplication and division, you can play with that a little bit. I mean, I can switch those two because they're multiplied together. I can swap them and make that A times B. It doesn't matter. So as long as there's a factor of A in the numerator and a factor of A in the denominator, they will become a 1. Now that's true, except where there's division. And remember, with division you have to reciprocate the divisor. Okay? We have to reciprocate the divisor. That changes things just a little bit. Just a little bit, but not much. Okay? Not much. Essentially what we would do here is you'd factor, and then you would flip that, and then once you've converted it to multiplication, it becomes one of the problems we were just talking about. In any case here, the easiest thing to do here is really just to take a look at a bunch of examples and make sure you see what I'm doing with every case. Okay, let's go through and we'll simplify the following here. So we have got 5x cubed divided by 2y multiplied by 8y over 15x squared. Okay, so now really to illustrate what I was trying to get at before, I'm going to make this question a little bit longer than it absolutely needs to be. Remember, I am going to multiply, okay, the numerators together. I'm going to multiply the denominators together. Okay. Now, with multiplication, order does not matter. So I am going to make this 5 times 8 times x cubed multiplied by y. I'm going to make the denominator 15 times 2 times x squared times y. Okay, now I'm going to run out of room here, so I'm going to move over here. So I can divide out the 5 over the 15. Well, there's a factor of 5 in 15. 15 is 3 times 5, so 5 divided by 5 is 1. I'm going to be left with a 3 in the denominator. 8 divided by 2, well, there's a factor of 2 in the 8. That's going to leave me with a 4 in the numerator. There are 3 factors of x in the numerator, 2 factors of x in the denominator. So that would be like x divided by xx. Well, there's going to be 2 pairs there that are going to cancel. It's going to leave me with an x in the numerator. And the y's are going to completely cancel. Y divided by y is just going to be 1. So I'm going to be left with 4x divided by, what am I left with? 3. That's it. That's the only thing that survived in the denominator. So 4x over 3. Okay, good. Now, in order to make this a true statement, though, because this statement is not 100% equal to this one, Okay, there are some differences here, and the reason there are differences is there's a couple of things going on here. Y cannot be allowed to be 0, and neither can X. Okay, those two restrictions exist in the original statement of the problem, but they don't exist in the simplified solution. So in order to make them equal, I actually have to mention that as a restriction. Now, this is equal to this at all points. And that's what I'm trying to do. I'm trying to simplify the expression. I'm not trying to change the expression. I'm trying to simplify it. This is equivalent to this, and it's equal as long as you maintain or you state those two restrictions. Over here, this one is a division statement here. So now, I'm going to factor as I go here. Well, I'm going to factor to start off with. So this will be 4m plus 2 divided by 3 n minus 1. So I'm just taking out the common factor. I'm going to leave this as division here for right now. 2m plus 3 divided by 7 n minus 1. Okay, now I'm not going to leave it like this, but I do want to note, and I'm going to maybe note this up top here just for now, that n cannot equal 1. It also cannot, well, can't equal 1. That's the same in both cases there. So good. Now, I'm going to convert this to its equivalent form. That's a multiplication statement. So 4m plus 2 divided by 3 n minus 1. I'm going to change it to multiplication. 7 n minus 1 divided by 2 m plus 3. Okay, now all of a sudden I've got this new non-permissible because I have something new in the denominator, and there m cannot equal negative 3. Now remember, I could change the order of the multiplication across the top and the order of the multiplication across the bottom. However, it doesn't really matter. There's an n minus 1 factor over an n minus 1. Those are going to become 1. The 4 divided by this 2 is going to leave me with that extra factor of 2 up there. Now m plus 2 and m plus 3, remember those are in brackets, so they need to be kept together. They're not the same. So I can't cancel the m's from that. I can only cancel the whole thing. So this is going to be equal to, what have I got here? I've got a 2 and a 7, so 14. M plus 2 survives to the end. I've got a 3 and an m plus 3. However, the restriction is that I wrote that wrong up here. Sorry, I just glanced up at it and realized I'd said it wrong. M cannot be equal to negative 3. So anyway, the two restrictions that survived that I need to include at the end here is n cannot equal 1 and m cannot equal negative 3. Now, I don't really need to state that, really. I don't need to, because it's clear to me from the simplified solution that I get. But this one definitely needs to be here, because it is no longer evident in this result that there was a restriction on n. So I need to include it. Let's take a look at this one. And I'll help you out here. This one right here is pretty hard to look at. So what I would do here is change this into something that's completely equivalent, but just easier to look at. That's much better to look at. It's far easier to process horizontally than it is to process vertically. That's just the way we are. So here we go. I'm going to start canceling in a second here, but just be aware here that I've got a couple of restrictions here. X can't be 0, neither can Y. Okay, because if X or Y goes to 0, the whole denominator goes to 0. I am going to, I'm trying to figure out whether I should, well, you know what, okay, let's simplify first. Okay, over here, I've got a 3 over a negative 6. That's going to leave me with a negative 2 in the denominator. I've got two factors of x in the numerator, 1 in the denominator, so it's going to leave me 1 in the numerator. And then the y squareds are both going to cancel. This whole thing is going to become essentially x over negative 2 or negative x over 2. Divided by, over here, what have we got? 4 divided by 2 is going to give me a 2 in the numerator. There are 3 factors of x in the numerator, 2 in the denominator. It's going to leave me with a single factor of x in the numerator. And then there are 2 factors of y in the denominator, but only 1 in the numerator. So it's going to leave me with 1 in the denominator when I simplify. Now, that does not alter the fact that that restriction still holds. X could not equal 0, y could not equal 0. Okay, let's change this division into its equivalent multiplication statement. And here it's even more clear that x cannot be equal to 0 because it just jumped into the denominator. Now, remember the freedom that I have with multiplication and division. I'm going to multiply straight across, multiply straight across. There's an x in the numerator, x in the denominator. Okay, I could, because order doesn't matter with multiplication, I could move that x forward and then have the x's cancel. So I would be left with y over negative 4, which I would typically write as just simply negative y over 4. But I have to, at the very end here, I have to state these restrictions that x cannot equal 0 and y cannot equal 0. And again, the reason I got to state these is because they are not at all obvious from this form here that those are restrictions. However, in the original question, those are clearly the restrictions. So I need to state that in conjunction with this to make those two equal to each other. All right, here, I'm going to do the same thing. I'm going to break these up into, whoops, sorry, that was too fast, into two sets of parentheses here, divided by, but I'm going to do a little bit of factoring as I go. Take out the common 3, take out the common 2. Here, there's nothing to take out there. Here, this is a difference of squares. Okay, so right now, as this one sits, my restrictions are n cannot equal negative 1. It can also not equal positive 1. And then here's another reference to the negative 1, can't equal negative 1. So those are my restrictions. So now, I would like to simplify within the parentheses if I could, but there's nothing shared numerator to denominator. So I'm going to move on to between the two sets of larger parentheses. So 3n plus 2 over 2n plus 1. I'm going to change that division into its equivalent multiplication. So this will be multiplied by n minus 1 multiplied by n plus 1 all over n plus 2. And I'm going to put parentheses around that to make sure that it's clear that those two need to be kept together. My restriction still holds, except now I can introduce a new restriction. I've got this n plus 2 down there, which means n cannot equal negative 2. And I'm writing it up here kind of out of the way for now. I'm going to bring this back in a second. Once it's written in this form, I bear in mind that once it's in a multiplication statement, that order is a little fluid, so I'm going to cancel the n plus 2 divided by n plus 2, gone. N plus 1 divided by n plus 1, gone. So what factors remain? Well, the 3, the n minus 1 in the numerator, and then just the 2 in the denominator. Now that is not entirely equal to this, because there are restrictions there that I no longer see, and those restrictions were that n could not equal negative 1, 1, or negative 2. Now those are equal statements. Awesome. Okay, I hope you're getting a sense of the pattern here. Now you're going to see a lot of division. And that's because when we practice division here at this very same time, we are practicing multiplication. So we're kind of hitting those two birds with the one stone there. Okay, let's try this one. First thing we're going to do is factor. So a plus 4, that one's already okay. And I'm going to put parentheses over that to show that that's got to be kept together. The denominator there has got a common factor of a to it, so I'll factor that out. We'll leave the division statement for right now. Okay, before I go any further, there's something about this question that I don't like it. It's not pretty. And it's this thing right here. This is not pretty. It's not pretty because it's in the wrong order. I like to have the a, the variable, first, and then even in decreasing, in order of decreasing degree. So I'm going to change the order of this. I'm just going to change this to negative a squared plus 16. That looks way better to me. But not perfect, not perfect. There's still something about this that I don't entirely like. And there will likely be a lot of you that can already guess what the issue is. I don't like the negative in the front. I would really prefer it if that negative wasn't there. So I'm going to factor it out. But if you factor it out, you have to factor it out of the whole thing. Now, I'm okay with there being a negative on the 16. I just don't like it on the a. And then if I'm going to do that, well, putting the negative down in the denominator is a little goofy. because it doesn't matter if the denominator is negative or the numerator is negative, I'm just going to move it up to the numerator. So this 1 over 16 minus a squared is really equivalent to negative 1 over a squared minus 16. That's way better. And now I will rewrite this. Okay, but now what I'm going to do is I'm going to factor that difference of squares that has popped up. This will be a minus 4, a plus 4. So I end up with the restrictions here. We're just running through the bottom here. First of all, a can't be 0, can't be positive 4, can't be negative 4. So we've got a small got a small handful of restrictions there. Now, I would like to simplify even before I get to the division if I can. So I'm going to look here and see if there's anything I can cancel. Nope. Look here, see if there's anything I can cancel. Nope. And so now I'm going to convert that division into a multiplication. So a minus 4, a plus 4 now in the numerator, negative 1 in the denominator. Now, I would like to check and see if that introduced any new non-permissibles to me, but it didn't. Okay, because what happened was the numerator here didn't have any places where it went to 0, so there were no new non-permissibles. Now I'm going to go through the process of canceling the ones out, if you will. A minus 4 divided by a minus 4 is 1. Then, there's nothing else I can cancel. The parentheses mean that I have to treat a plus 4 as a unit. A plus 4 as a unit. So what I'm left with here is this negative a plus 4 squared in the numerator and an a in the denominator. Oops, you can't see. I'm sorry, you can't see that. A plus 4 squared in the numerator and then just that a in the denominator. And that negative makes the whole thing negative. Now, I have to stipulate a few things. Because I lost a term in the denominator there, actually I lost two of them because I multiplied by the reciprocal, I have to state that a cannot equal 4 or negative 4. Those ended up disappearing. Okay? But I should also state that a can't equal 0. Now, it's not absolutely necessary to state that a can't equal 0 because that's a restriction that survives to the end of this problem. However, if you want that mark, you got to write it down. Okay? Because we want you to write down all of them. Let's move along here. Oops. Whoa, there we go. So, first thing I want to do here is like we've been doing before is I want to factor x to the 4th minus 16. That's a difference of squares. So x minus 4, x squared plus 4 divided by, in this case right here, it's not a difference of squares, but it's, well, I mean, you could consider it a difference of squares. I shouldn't actually say that. But it's probably more direct to take out the common x squared, make that x squared minus 4, divided by, and then here, take out the common x, so x squared plus 4, and then we have here x plus 3 squared. Now, I should state the non-permissibles. Well, actually what I should do is I should do a little bit more factoring, except that I can see, like normally what I would do is I would factor this x squared minus 4 over this, and then x squared minus 4 here, but those are going to cancel in a bit, and I don't even know if it's worth the work. So what I might say here is, first of all, x squared can't equal 0, which means if x squared cannot be equal to 0, that means just x can't equal 0. And then I've got this other one here. I see that x squared cannot equal 4. Now think about that. If x squared can't equal 4, then that means x can't be the square root of 4. Or the negative square root of 4. It can't be either plus or minus 2, because if you square either one of those, either the positive 2 or the negative 2, no matter what, you're going to get positive 4 there. When you plug that in, subtract that 4 from it, it's going to go to 0, so I can't let that happen. And then over here, I've got this one last restriction here, x can't be equal to negative 3. So I've got a bunch here, 0, plus or minus, okay, and I'll identify these. 0 from there, plus or minus 2, negative 3. Now notice I don't worry about the plus or minus here because the square is on the whole expression, not just the x there. Anyway, now what I would do is I would look at this as, can I simplify either side here? And yes, I can. The x squared minus 4 is going to disappear. And so then this becomes x squared plus 4, and I'll put parentheses around that to keep it together. over x squared divided by x over x squared plus 4 over x plus 3 squared. There's no other simplifying that I can do. In other words, no other canceling I can do to create a 1. So now I'm going to convert this division into its equivalent multiplication. And this will become x plus 3 squared over x squared plus 4. And now I'm seeing a factor of x squared plus 4 in the numerator and the denominator. Those will disappear. We're simply left with an x plus 3 squared in the numerator. And in the denominator, notice I've got an x squared here and an x there, so that's going to give us x cubed. And again, I'm going to write that out here. So it reduces down to this, but they're not equal until I state that x cannot equal 0, can't equal plus or minus 2, can't equal negative 3. Again, this one here, the 0, isn't absolutely necessary because I can see it there that it can't equal 0, but these three are absolutely necessary because I've lost the factors that indicate where those restrictions came from. All right, let's take a look at this next one. So first thing I want to do here is factor. And now notice this one is multiplication, so I don't need to worry about multiplying by the reciprocal. So x squared plus 1, well, this is going to be x, and this has got to be 1 and 1. And so this is positive here, which means both signs are the same, and since this is positive, they're both positive. Now, does that work to get me x squared plus 2x plus 1? 1x, yeah, 2x. The denominator, take out the common 4. Whoops, can't believe I was just about to do that. X minus 1 multiplied by 12 over x plus 1 squared. Okay. Now, at this point here, we want to state the non-permissibles, and the non-permissibles are that x cannot equal positive 1 or negative 1. Okay? Now, let's cancel out terms that are shared, numerator and denominator. X plus 1 squared means there are two factors here. Well, lo and behold, there are two factors up here, so both of those are going to cancel with that one. 12 has got a factor of 4 in it, so when you cancel out that, you're going to be left with a 3. And so when all's said and done, all that survived in the numerator was a 3, x minus 1 in the denominator. I can see the restriction that x can't equal positive 1. What I can't see is the restriction that x can't equal negative 1. But I should include both. Okay? Just to guarantee that your teacher knows that you know what the restrictions are. So the next one. All right, now we're right back to division. Now, don't let the way this question looks throw you off. Okay, don't let it intimidate you. First thing I'm going to do is I'm going to clean up one little bit here. There is one little bit here that I really don't like how it looks, and that's this one right down here. So what I'm going to do, actually I might even just do it right up here. I'm going to change the order of this, make it negative m squared plus 9. Okay, that looks better to me because the variable is coming first. Now, but I don't like the fact that the variable is negative, so I'm actually going to take that negative out. But when I do that, it's going to change all the signs in that binomial. So this becomes negative m squared minus 9. I much prefer that to the way it looked before. Now I'll go through the process of factoring everything. So my numerator is going to be 3m. Okay, that's the only way 3m squared can be broken down. Now, factors of 2 are going to be 1 and 2. So the question is, how am I going to do that to get a negative 5 there? Let's try 1 and 2 first. Since this sign is negative, I know that these have different signs. And since this number here is negative, I know that when I multiply these two out here, the larger one's going to be the negative. So that suggests to me that this should be negative 2, positive 1. 3 times negative 2 is negative 6. Plus that 1, when you put those together, that is where that negative 5 is coming from. So that's how you factor that. The denominator has got a negative in front, and then I recognize what's left over as a difference of squares. So negative m minus 3, m plus 3. Divided by, again, there's a 3m there, so this has got to be 3m and m. I've got a 3 over here, so I know that these two factors are going to be 1 and 3 or 3 and 1. Now, if I put a 3 here, then I'm creating a situation where there's a common 3 in this factor, but there isn't one here, so it's got to look like that, so that I don't create a common factor where one doesn't exist. This is negative, so they'd have different signs. This is negative, so the larger number here is going to be negative. That means this has got to be negative. 3 times negative 3 is negative 9, plus 1. Okay, there's my negative 8. In the denominator, and I know factoring is frustrating for a lot of people, okay? I recognize this. If this is going a little fast there, by all means, you know, go back, look over it again, but just, you got to convince yourself that I'm doing this correctly here. 2m squared can only be broken up into 2m and m. Now negative 15, it's negative. Okay, so one of the two factors is positive, one's negative, and since this one is positive, that means the larger multiple has got to be positive here. Now, with the 2 there, if I put 3 and 5, if I make this 3 and 5, I'm going to get 10 and 3. Well, there's no way 10 and 3 are going to add to get me the 1 that I see in this original question. So it's got to be 5 and 3. That's going to give me 6, and there it is, 6 and 5. So as long as this is positive 3, negative 5, that becomes positive 6 minus 5m. There's my 1m there. Awesome. Finally, I got it. Now, up here, I'm going to quickly state the non-permissibles that I'm seeing. And just so that I've got it off to the side, then I'll come back to it. Can't equal 3. Can't equal negative 3. This is a little bit more complicated because of the 2 in front, but bring the 5 over, divide by 2. That's going to be positive 5 halves. And then here, once again, is that restriction, negative 3. Now, I am going to convert this into the equivalent multiplication statement. So this will become 2m minus 5, m minus 3, sorry, m plus 3, over 3m plus 1, m minus 3. Now I'm going to look for, in the numerator and denominator, again, because this is multiplication, I can do this in whatever order I want, so I can move things around. 3m plus 1 will cancel with that, become a 1. m plus 3 will cancel. That actually looks like that's about it. So in the numerator, I'm left with m minus 2, 2m minus 5, over m minus 3, m minus 3. And don't forget about that negative. Nothing actually ever happened to that negative, so I might even just put the negative out front here. Now, the original function is equal to this one so long as we state, oh, sorry, I forgot one of my non-permissibles. I can't believe I forgot that. As soon as we did the reciprocal, sorry, that introduced another non-permissible there. The non-permissible was negative 1/3. Sorry, I completely forgot about that one. Here, I have to state my non-permissibles. I very specifically have to state that m cannot equal 5 halves and negative 1/3. I have to state those ones because they no longer exist as non-permissibles here. But I should also indicate the 3 and the negative 3, really just to get that mark there. Now, this does put us in a weird position. You might be expected to multiply out the numerator. Now, I'm going to do that right now. But I want you to know that the denominator is very seldom ever, we hardly ever expect you to expand that out. In fact, it's far more useful when it's in factored form. However, the numerator, you might. So 2m squared, that's going to be negative 5m minus form, so negative 9m plus 10. And then again, when m cannot equal 5 halves, negative 1/3, 3, or negative 3. Okay? So this might be good enough for your answer, but you might be expected to go that far. The reason I put parentheses around that is because of the negative that sits out front. Let's look at another one. All right, once again, a division statement here. Let's factor it. So in the numerator, I can take out the common x. The denominator is a difference of squares. Divided by, and then this is going to be x plus 3, x plus 2. And again, I'm putting those in parentheses here so that I can see clearly that I need to keep them together as one unit. X and the 3 are not separate items here, they go together. My non-permissibles right now are that x cannot equal 2, -2, or -2. Okay, that's fine. That's repeat. I don't need to do that. Now, is there anything I can simplify, cancel right now? The answer is no. So I'm going to convert this division into a multiplication. Again, that restriction still holds, except now I've got another one. X can't equal 2, -2, or in this case, -3. And so now x plus 2 are going to become 1. X plus 3 is going to become 1. The only terms that survive are x, or the only factors that survive are that x and the x minus 2. And again, I have to state specifically the -2 and the -3, okay, because without those, they're not equivalent. But I should also state the +2 because I have to jump through that little hoop. This one. Again, it's a division statement. Let's factor. So that numerator is a difference of squares. 2x minus 1, 2x plus 1, all over x plus 2. Divided by, okay, now here I've got a common 2x. It's going to leave me 2x plus 1. Here, if I take out the 8, that's going to leave me with x squared minus 4, and I'm really lazy. So what I'm going to do right now is I'm going to factor that down because I can recognize that's a difference of squares right away. That'll be x minus 2, x plus 2. Okay, so just taking out that 8 there, I can see the difference of squares, so I'm just going to factor it right now. Here, x cannot equal -2 or +2. And right now, that's it for my restriction. Now, is there any simplifying I can do right here? Nothing there. Okay, a little bit of simplification. I can cancel out the factor of 2, shared numerator denominator, but that's it. So now I'm going to convert this into its equivalent multiplication statement. So 2x minus 1, 2x plus 1, all over x plus 2, now multiplied by 4, x minus 2, x plus 2, divided by x, 2x plus 1. In terms of the restrictions, I've now got a new restriction, or actually, sorry, I should say a couple new restrictions. -2, +2, 0, and -1/2. Okay, those are also restrictions on that variable. Because this is now in the form of a multiplication statement here, the order of the numerators, the order of the denominators, they can switch those around, so I can cancel 2x plus 1 with 2x plus 1, and the x plus 2 with the x plus 2. So I would be left with 4, 2x minus 1, x minus 2, all over just the x, where x cannot equal -2, +2, 0, or -1/2. And out of those restrictions, really, the only one that wasn't absolutely necessary, was the 0, but we put it in there just to make sure we get the mark, right? Is this a good enough answer? Probably. Again, it all depends on your teacher here. You might be expected to multiply that out, in which case you're going to get, what is that, 2x times x is going to be 2x squared, multiplied by the 4 is going to be 8x squared. It'll be -4 minus 5, sorry, -4 minus 1 is -5, times 4 is -20. +2 times 4 is +8, all over x. And then again, x cannot be equal -2, 2, 0, -1/2. Now, technically, I should be writing those restrictions all of the time with almost every step, well, with every step that I'm doing where I have specifically canceled stuff out, but really, most of us instructors are going to be just happy if you keep it with the final answer. But you do need to keep it with the final answer. If I stop writing it right there, if I wrote it up here or wrote it up here, it looks like it's no longer a restriction once I go down to this step. And I know you're like, oh, come on, please, do I have to? Yes. Yes, you do. Next. Oh, look at that. That's a beast. But just take it one step at a time. Don't freak out. The first thing you got to do is, well, okay, the first thing I would do here is make anything pretty that doesn't look pretty. But right now, everything here seems to be in the right order with no weird stray negatives. So, okay, perfect. I like that. So now just factor. And just take it one at a time. So a squared minus 8a minus 9. Okay, so this has got to be a and a. Okay, and if I'm going to get my factors of 9 to go to 8 here, that's got to be negative 9, positive 1. Okay? Yeah, and those will give me negative 8 there. Here, this has got to be a and a. And then the factors of 72 that give me 17. Okay, and this is positive, so these are both the same sign, and they both got to be negative because of that negative. This has got to be negative 9 and negative 8. Multiplied by, do it again. This is going to be a and a. Okay, factors of 8 that give you negative 9. Well, it's got to be negative 8, negative 1. Down here, this is a difference of squares. So a plus 1, a minus 1. And you'll see that I'm purposely lining stuff up here. Divided by, okay, I'm going to probably run off the screen here, and that's okay. It's got to be a, and then factors of negative 5 that add to positive 4. Okay, well, it's got to be positive 5, negative 1. And down here, this will be a plus 5, a minus 5, another difference of squares. All right, so let's just sneak up here, and let's say what a can't be. Well, a can't be 9. Can't be 8. Can't be negative 1. Can't be positive 1. Can't be negative 5. Can't be positive 5. So got a whole bunch of restrictions there. Now, I am going to flip this. Okay? So I'm going to have a minus, well, okay. So before I do that, because I am essentially lazy, I'm going to start to cancel things that really aren't necessary anymore. These two are not necessary anymore. I lined those up. These two are not necessary anymore. Because of the way multiplication works, everybody look at this. A minus 8, a minus 8, a plus 1. This whole thing becomes 1 as long as I obey these restrictions. On the other side, in my divisor, that cancels with that, as long as I'm following my restrictions here. Now, what this leaves me with here is 1, and actually I'll be fair with this so that it's as clear as possible. 1 over 1 divided by a minus 1 over a minus 5. That's what survived. I've already stated all the restrictions. I'm going to convert the division into a multiplication. I really should have put parentheses around all that. And when all is said and done, when you multiply those across, we're simply left with a minus 5, a minus 1, which is true as long as you state that a can't be 9, 8, negative 1, positive 1, negative 5, positive 5. So I need all of that, well, all of it really except the positive 1, but I need all of that in addition to this statement right here, because all of these restrictions disappeared in reducing it down to this expression right there. But I can't change the expression, I need it to stay the same.